What is 3/6 plus 2/6? Well, first I will need to get 3/6. 1/6, 2/6, and 3/6.
I would like to note, in this case, red is positive. It is simply another color to distinguish it from yellow, which we'll be using shortly.
Then I would need to get 2/6 more because of the second number. 1/6, 2/6. To find what 3/6 plus 2/6 is, I need to find what the total would be when I combine them. And that total is 1/6, 2/6, 3/6, 4/6, 5/6. So 3/6 plus 2/6 is equal to 5/6. Suppose that I didn't want to use this model. How could I solve the problem nevertheless? Well, the first thing I would like to note is that the numerators, that is, the numbers above the line in the fractions, add up. 3 plus 2 is equal to 5. This makes sense because if I were to solve 3 plus 2, I would get 3 pom-poms and then 2 more pom-poms and find the total 1, 2, 3, 4, 5. And this may seem a little familiar because it was exactly what we just did, except everything was in 6, which is my second point I would like to make. The denominators, that is the numbers below the line in a fraction, are all the same. You cannot add two numbers that don't have the same denominator. And the answer you get when you add, that is the sum, has the same denominator. I would like to note that this idea of doing the operation on the top, that is where the numerators are, and doing nothing on the bottom, that is where the denominators are, and making sure the denominators are equal, that is the same for subtracting fractions. Suppose that I want to solve 5/6 minus 2/6. Well, here I have 5/6. Then I take away 2/6. What am I left with? 1/6, 2/6, 3/6. So 5/6 minus 2/6 is equal to 3/6. The numerators are subtracting. If I were to solve 5 minus 2, I would get 5 and take away 2. And I would be left with 1, 2, 3. This is the exact same motion of what we just did, except everything was in 6. That is the second point I would like to make. The denominators are the same for subtraction like they are the same for addition. Now suppose that I want to solve 2/8 plus 5/8. Well, first I would need to get 2/8. Then I need to get 5/8 more. To figure out what 2/8 plus 5/8 is, I need to figure out what the total would be if I combine them. And the total is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. So 2/8 plus 5/8 is equal to 7/8. Suppose that I don't want to use a model to figure out what 2/8 plus 5/8 is. Is there an easier way? Yes, there is an easier way. First, the numerators, that is the numbers above the line in a fraction, are being added, as you can see from here. 2 plus 5 is equal to 7. This makes sense because if we don't think of these as fractions anymore, but think them as slices on a pizza, and we have 2 slices and then 5 slices, and we combine them together, we're going to get 7 slices. 1, 2, 3, 4, 5, 6, 7. 7 slices. Except that in this example, everything is in eighths, which brings me to my second point. The denominator stays the same when you add fractions. You cannot add 2 fractions together unless the denominator is the same. And the answer has to have the same denominator as the numbers that are being added together. I would like to show that subtracting fractions is similar to adding them. Suppose that I want to solve 7/8 minus 5/8. Well, here I have 7/8. To subtract 5/8, I simply take 5/8 away. How many parts do I have left? 1/8, 2/8. I have 2/8 left, so 7/8 minus 5/8 is equal to 2/8. Now, how could I solve that without using this model? Well, the first thing I like to note is that the numerators are subtracting. That is, that the numbers above the line which fractions have are subtracting. Why does this make sense? Well, suppose that I have a pizza and I have 7 slices of pizza and I take 5 away. I would have 2 slices left, and this method is exactly the same as in this model, except in this model everything is in eighths, which brings me to my second point. The denominators, that is, the numbers below the line, are all the same. You cannot subtract 2 fractions with unlike denominators. The answer, that is the difference when you subtract, has the same denominator. What is 3/12 plus 7/12? Well, first I need 3/12. Now I would need 7/12 more. To figure out what 3/12 plus 7/12 is, I need to know what the total is when I combine them. And the total is 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12. So 3/12 plus 7/12 is equal to 10/12. Now, how could I solve that without using this model? Well, to note, the numerators, that is the numbers above the line, are adding. This makes sense because if I think 3 pieces of pie and I'm adding 7 more pieces of pie, and then I count the total, I'm doing the exact same method, except in this example, everything is in 12ths, which brings me to my second point. The denominator stays the same throughout. You cannot add 2 numbers with a different denominator. And the sum, that is the answer after you add, has to have the same denominator. I would like to give another example of why subtracting fractions is similar to adding them. What is 10/12 minus 3/12? Well, here I already have 10/12. To subtract 3/12, I simply take away 3/12. How many do I have left? 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12. So 10/12 minus 3/12 is equal to 7/12. How could I solve this without using a model? Well, to note, the numerators, that is the numbers above the line, are subtracting. 10 minus 3 is equal to 7. This makes sense though. If I have 10 pieces of pizza and I take 3 away, I am left with 7. And this is the exact same method we are using now, except now everything is in twelfths. Which brings me to my second point. The denominators are all the same. The next video in the set of videos is parts 4a and 4b, which are the first parts about when you include negative numerators. This video explains the why behind for adding fractions in a certain way by using counters. If you would like to watch this video, please click the link here. If you would like to skip the cases of where you include numerators and or denominators of negative numbers and or non-integers, please click the second link if you would wish. The second link goes over part 8, which is when you include numerators of 0, and part 9, which is when you include denominators of 0.